Good morning friends. Welcome back to Parnika tutorials. In this video, I want to discuss what is an Armstrong number and then I will discuss a C program to check whether a given number is Armstrong number or not. Lot of students can easily write this program for a 3-digit number. But if I ask them to do it for an n-digit number, they will fail to do it. So in this video, I want to discuss the program for an n-digit number. So I request everyone to watch the complete video for better understanding. Before discussing the program, let me discuss what is an Armstrong number with an example. Let's take that you have a number 153. Now compute how many digits are there. The number of digits in this number is 3. So you take the individual digit and compute the cube of it. So 1 power 3 and 5 power 3 and 3 power 3. The individual digits are 1. So I am computing the 1 cube. Another one is 5. I am computing the 5 cube. And another number is 3, so I am computing 3 cube. So after computing them, I have to perform the addition. So 1 cube is 1, 5 cube is 125, 3 cube is 27. So which is equal to 126 plus 27, which is equal to 153. So after performing this one, if you are getting the original number, you can say that the given number is Armstrong number. Now look at here. The given number is 153 and after computing this operation, still you are getting the 153. I can say that it is an Armstrong number. Let me take another example. I am taking a number called 1143. Now first thing is that I need to check how many digits are there. The number of digits are 4. So take the individual digit, compute the power of 4. 1 power 4, 1 power 4, 4 power 4, 3 power 4. So 1 power 4 is 1, 1 power 4 is 1, okay. 4 power 4 is 256, which is nothing but 2 power 8, 2 power 8 is nothing but 256 and 3 power 4 is 81. So if you compute the addition, you are getting the 258 plus 81, which is equal to 9, 13, 339. So after computing this one, you are getting 339, which is not equal to original number. So I can say that the 1143 is not an Armstrong number. So now you have understood what is an Armstrong number with an example. Let me discuss this program. Okay. We will use hash include stdio.h, which is a standard input-output header file. And even we will introduce this math.h header file. This header file will consist of all the inbuilt functions related to Mac, such as power, all these things. Okay. Now, let me do it. I'm writing a void main. I need to declare what are the variables are required for me. I need an integer variable, so I'm using the data type called int. I'm taking a variable num, which consists of the original number. I will take on, which is a original number, or you can write original number also. And let me take the variable as remainder. I will take the variable as result is equal to 0. And also I will take a variable called n is equal to 0. This n is equal variable is required for me to check the number of digits in the given number, because first I need to find the number of digits. When I have discussed 153, first we have computed the number of digits. So this n variable is required for me to count the number of digits. And this result, finally you are getting this result. To store that one, I am using this variable called result. And every time I will use the remainder to compute. So that is the way I am using this variable, and you understood the num and on. Okay. Now first what I need to do, I need to ask the user to enter the number. So printf enter the number, okay, for which the user need to check whether it is Armstrong number or not. Once he has entered, I need to read it. So I'm using an inbuilt function called scanf, and I need to read an integer. So I'm using the format specifier %d, and that number I want to store it in a variable num and in the address location. So that's why I'm using like this. So now first thing what I need to do, I need to count the number of digits in this value what is there in this variable. Okay. Now what I will do is that I will use the while loop. Okay, before doing that one, I need to do one thing. What is that one is that I need to store this number in another variable called on, because I should not lose this value which is there in this variable num, because finally I need to compare the num with this final result. If it is matching, then only I can say that it is Armstrong number. So I should not lose this num. Okay, so that's why what I am doing, I am taking a variable called on this one I will do all these tasks. So while on or original number not equal to 0, what I will do is that on is equal to on divided by 10. Okay, and then I am performing the n plus plus. Okay, now what it will do is that it will compute the number of digits in the given number. Let's take that the given number is 12. Okay, let's take that it is 12. Now tell me how many digits are there. It is 2 digits are there. Okay, now look at whether finally the n is consists of value 2 or not. Initially what is the n value? N value is 0. Okay, now what is the on is consists of 12. Now look at 12 is equal to 0. No, 12 is not equal to 0. So that is what the statement here it is written. On not equal to 0. On is consists of 12. 12 is not equal to 0. So the condition is satisfied. If this condition is satisfied, what are the statements which are there in the while loop will be executed. Now what is the first statement is consists of? On is equal to on by 10, which is a division operator. Division operator will give you the quotient. So 12 by 10. What is the quotient? You will get the 1. So now initially on is consists of 12. Now after execute the statement, you will get the 1 here. And n plus plus. N value is incremented to 1. Okay, currently n is consists of 1. Now look at it. Again this test condition will be checked. On, what is the value? 1. 1 is not equal to 0. So again this condition is true. So these two statements will be again executed. What is the first statement? On is equal to on by 10. So 1 by 10 you will get the value 0. So on is currently updated to 0 and n plus plus. So n value will be again incremented, which will be updated to 2. So look at this one. After execute this statement, again you will check the test expression. What is the text expression? On not equal to 0. What is the value currently is there in the on? 0. So 0 is equal to 0. This condition is failed. Now look at once this condition is failed, what is the n value? 2, which is equal to number of digits in the given number 12. Okay. So we have done the half of the program correctly till now. Now we need to finish this program. Okay. Now how I will finish this program is that now once I got the digits, I need to compute the powers of it. So what I will do is that, okay, now again I will update on is equal to num, because currently on is consists of 0. Again I will keep on is equal to num. Then again I will do while on not equal to 0. Now this time I need to find the each digit in this given number. So to do that one, what I will do is that I will compute the remainder. Remainder is equal to on modulus 10. Okay. So now what will happen? Let's take that I am taking 153. Okay. Are you able to understand? Now what is the remainder will consist of? Remainder is not consist of any value initially, or you can take 0 also. Remainder is equal to on modulus 10. 153 modulus 10. What it will give? It will give the modulus will give you the remainder, whereas the division will give you the quotient. So if you do 153 modulus 10, you will get the remainder as 3. Will you agree with me or not? So it will give the this 3. Now what you need to do? You need to take the statement called result is equal to result plus power of, okay, remainder comma n, where this n is the number of digits, because here what you need to do, once you got the 3, you need to compute 3 power 3, because the number of digits are 3. So that's why I am doing power of remainder comma n. Okay, so this function will do is that it will compute the remainder power n. That is the use of the power function. Now you can ask me, sir, you can simply compute the power of remainder comma n. Why you are writing result is equal to result plus 1? Because after this one I need to store this value, because 3 power 3 I will get 27. Then I need to compute 5 power 3, but that value 27 plus 5 power 3 I need to do. So that's why result is equal to result plus power of remainder comma n I am writing. Then what I need to do, on is equal to on divided by 10 I have to do. This is the statement to compute this result. Okay, look at it with an example. Let me discuss with an example. Let me take a simple number again, 12. 12, I will get the number of digits as 2. So n is consists of 2. Will you agree with me or not? Okay. Now look at this one. On is equal to num. So even on is consists of number 12. Now what is the condition? While on not equal to 0. Currently on is consists of 12. 12 is not equal to 0. The condition is true. If the condition is true, what are the statements? These three statements. Okay, these three statements will be executed. Okay, these three statements, what is the first statement? Remainder is equal to on modulus 10. On is consists of 12. 12 modulus 10, which is equal to 2. So the remainder is consists of value 2. Okay, now you have written a statement called result is equal to result plus power of remainder comma n. What is the result? Initially consists of value 0. So 0 plus power of remainder is 2, n value is 2, which is nothing but 0 plus 2 power 2, which is equal to 4. Now the result will be updated as 4. Keep it. Okay, are you able to understand? Then on is equal to on by 10. Now 12 by 10, it will give you the quotient which is 1. So on will be updated as 1. Are you able to understand? Again you will check this condition, on not equal to 0. 1 is not equal to 0. Yes, again the condition is true. So if this condition is true, these three statements will be again executed. What is that? Remainder is equal to on modulus 10. So what is the on consists of 1? 1 modulus 10, you will get the 1. So remainder is currently consists of value 1. Result is equal to result plus power of remainder comma n. What is the result? Is consists of 4. 4 plus power of 1 comma 2, which is nothing but 1 power 2, which is equal to 4 plus 1 is equal to 5. Now the result is consists of value 5. Now you have written statement called on is equal to on by 10, which is nothing but 1 by 10, which is equal to 0. Now you got the on value is equal to 0. Again you will check that condition, whether on not equal to 0 or not. 0 is equal to 0, so this condition is failed. So you have completed executing this while block. Now what you need to check, whatever the result you are getting, whether it is equal to given number or not. That is the final thing you need to do. So you will write a statement called if result is equal to given number n, okay, result is equal to given number num, then I can say that it is an Armstrong number. You can write that the given number is Armstrong number, or you can write Armstrong. Else, if it is not equal to num, then you can say that printf not Armstrong. Okay, then you can write the get ch and you will close it. Okay, so this is the program to check whether a given number is Armstrong number or not for an n digit number. First task is that you need to compute the number of digits in it, and then you need to compute the value, and then you need to check whether the result whatever you are obtaining is equal to given number or not. If it is matching, then you will say that it is an Armstrong number, else you will say that it is not an Armstrong number. If you still have any doubts related to this video, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.